Good morning everyone. Today I am going to share with you a simpler way to remember graphs, range and formulae of inverse trigonometric functions. Because this chapter has a weightage of 5 marks which is bifurcated in 1 marker and 4 marker question. So let's first of all discuss about the graphs. We have sin x graph. Now you have to remember, and you have also read in class 11, that sin x has the value 0 at n multiples of pi. So it is passing through the origin and at multiples of pi it is having value 0. Cos x is 0 at odd multiples of pi by 2. So at odd multiples of pi by 2, that means pi by 2, 3 pi by 2 minus pi by 2, 3 pi by 2, the value is 0 and it is not passing through the origin. And in 10x, it is again 0 at n multiples of pi, where n is any integer. So here it is passing through 0, then it is passing through pi, n multiples 0, pi, 2 pi, 3 pi. From this side it is minus pi, 2 pi, minus 3 pi and so on. Now if we want to find the graph of the inverse functions, then what you have to do, you have to just flip this graph and you will get the graph of sin inverse x. Similarly, flip the graph of cos x, you will get graph of cos inverse x function. If you are going to flip this, then you will be getting tan inverse x graph. Now you see, I have darkened some of the part of the graph. This darkened part is the principal value branch. What is that principal value branch? It is that main part of the graph by which I can frame the rest of the graph. If I take this part and if I place it like this and this, then I'll be framing sin inverse x graph. If I take this darkened part and then I place it like this, then I will be able to frame the rest of the part. So this part is known as principal value branch, and this branch is from, for sin inverse x, this branch is from minus pi by 2 to pi by 2. This is from pi to 0 to pi. This is from again minus pi by 2 to pi by 2. But we will not include minus pi by 2 because at pi by 2 it becomes infinity or not defined. Now I will tell you a super trick to remember range of all these inverse trigonometric functions. You just draw the quadrants and you see out of these 6, they are just taking the values minus pi by 2 to pi by 2 or 0 to pi. So you remember in this sequence, we know that sine, cos and tan are the basic trigonometric functions. So we will start in this order only. Then we will discuss about their reciprocals. Now you see, sine inverse x is taking the value minus pi by 2 to pi by 2. Basically, all these 6 inverse trigonometric ratio are moving in just 2 quadrants. For sine inverse, you remember it like this. This is 0 degrees, this is pi by 2, this is minus pi by 2 and this is your pi. So for sine inverse, you have from minus pi by 2 to pi by 2. For cos inverse, you have from 0 to pi. For tan inverse, again you are moving from minus pi by 2 to pi by 2, but it is your open interval because at pi by 2 it is not defined. That's why we are writing it in closed intervals. Now for cosec inverse, you will be looking at sine inverse. Sine inverse is closed interval minus pi by 2 to pi by 2. So here I am writing same as minus pi by 2 to pi by 2, but I am excluding this value 0 because at 0 it is not defined. Similarly, sec inverse is reciprocal of this and minus pi by 2 is not included because it is not defined there. Tan inverse x, of course, cot inverse x, but here you have to remember because it has a different value. So everywhere you are moving from minus pi by 2 to pi by 2 and 0 to pi, minus pi by 2 to pi by 2 and 0 to pi.